Welcome everyone to EET 261 Electronic Communications. I would like to go over your midterm exam. Question A, communications is the process of exchanging information. That's true. Question B, simplex communication is two-way. That's false. Question C, full duplex communication is one-way. That's also false. Question D, noise is anything that degrades the intelligent signal. That's true. Question E, gain implies that the signal has been sufficiently degraded. That's false. Question F, the process of modulation refers to the multiplication of the intelligence and the carrier signals. That's true. Question G, a resistive voltage divider circuit would be an example of an attenuator. That's true. Question H, a decibel is a logarithmic response. That's true. Question I, a diode detector would be one example of a demodulator circuit. That's true. Question J, an oscilloscope displays waveforms in the time domain. Question K, a spectrum analyzer displays waveforms in the frequency domain. Question L, the carrier is the high frequency signal. Question M, the intelligence is the low frequency signal. Question N, calculate the wavelength of a 150 megahertz signal. So what we have to do, remember lambda is equal to c divided by f, where c is the speed of light and f is the frequency. So for the speed of light, we're going to use 3 times 10 to the 8th meters per second divided by the frequency. And remember, you have to convert megahertz into base frequency. So 150 megahertz is 150 times 10 to the 6th. Divide top by bottom, and I will get a wavelength of 2 meters. Question O, calculate the frequency of a 400 meter signal. Again, using the equation lambda is equal to c divided by f. I just rearrange algebraically and solve for frequency. Frequency is equal to c divided by lambda. So again, the speed of light, 3 times 10 to the 8th meters per second. The wavelength is 400 meters. Divide top by bottom, and I will get a frequency of 750 kilohertz. Question P, an amplifier circuit has an output power of 6 watts and a gain of 80. Calculate its input power. A sub P is equal to the output power P sub O divided by the input power P sub in. So what I'm going to do is rearrange algebraically to solve for P sub in is equal to P output divided by the power gain. So plug the numbers in, 6 divided by 80 will leave me with 0.075 watts or 75 milliwatts. Question Q, AM stands for amplitude modulation. Question R, all signal processing circuits involve gain or attenuation. That's true. Question S, draw the AM waveform in time domain. The AM waveform in time domain is going to look like this. And we normally refer to this as the envelope. And the last question, question T, the third harmonic of a 120 hertz signal is 400 hertz. All you have to do is take the original signal of 120 hertz multiplied by 3. That would be 360 hertz. So question T would be false. Thank you.